What's up, friends? How's it going? This is Kathryn Whitaker with Piper Aircraft. Good to be here with you guys again. So, if you don't remember me from last year, I am an aircraft accident investigator. My official title is Air Safety Investigator. And that basically means that I work for Piper Aircraft, assisting the NTSB in doing aircraft accident investigations, usually within the United States, but also we also travel globally on occasion. And today I would like to talk to you about aircraft fuel systems, which has been a recurring hot button issue within the accident investigation community for some time now. And recently there have been some accidents that have been more high profile lately involving these types of failures, aircraft mechanical failures. So I would like to talk to you a little bit about this, and I'm going to be referencing some case studies. I was told this was popular last year, so you'll be happy to hear that I'm going to be doing more of these today. So without further ado, let's get on into it. So just to touch on some statistics from AOPA's NOL report, in 2020 alone, which is the most recent year that they have done a more detailed publishment of the information on, there were 153 general aviation or small aircraft accidents that were caused by mechanical problems, which was about 17% of overall accidents, and 26% of these maintenance-related accidents were problems with the fuel systems. Another 58 accidents were related to fuel management, which usually relates to the pilot perhaps not bringing enough fuel on board, overdoing the endurance of their aircraft, maybe not switching tanks when they were supposed to. Fuel system failures tend to fall under kind of 4 different categories. And some of these can, or all of these could be happening all at once within a failure. They include things like fuel flow interruption, loss of fuel where it's leaking, it's leaving the aircraft, contamination. There's something in the fuel that does not belong, typically water or other things. We also can have fuel quantity indication errors, and we'll be talking about all 4 of these things today. Each of these can result in engine power loss, and leakage can also cause fires. So we have many different hazards to flight when these things happen. These problems can occur together, or they can cause one another. So usually when you think of a fuel system failure, you're going to think of fuel starvation, which is lack of fuel getting to the engine or engines, fuel flow interruptions, things like that. And maintenance-related fuel flow interruptions can come from multiple sources. So you can have improper material usage. You can use the wrong sealant, sloshes. You can use fuel filters can be inappropriate. You can be putting the wrong gaskets, installing the wrong gaskets in the fuel system. You can have foreign objects, including things like water, that are entering the fuel system. Vents, the blockage of vents can cause interruption to fuel flow. Disconnection or damage to lines and fittings. And you can also have wear or deterioration of the selectors and valves. And any of these things, all these things could be occurring on one aircraft if it's in kind of a troubled mechanical state. So be alert to these things. We have a classic example right here. This was actually one of the very first accidents I ever investigated. This is a Cherokee 6. It had a mishap in 2018 in Reno, Nevada. And as you can see here, we've got a disconnected fuel line. This, I believe, was the fuel line that was going from the outlet of the mechanical fuel pump, the engine-driven fuel pump, to the fuel servo or the carburetor. I don't remember if it had a servo. It looks like a servo there. This aircraft was undergoing maintenance at the time. This was somewhat of a frustrating case, and I'm sure many of you mechanics here will be very annoyed with this story that I'm about to tell you. But this aircraft was undergoing maintenance. Specifically, it was receiving it was a suite of engine data monitoring equipment, including a fuel flow sensor, feeding into an engine data monitor that was being installed on the instrument panel, which is, they're great systems. I honestly advocate for these on to pilots more than any other instrument that you can get if you're flying VFR, especially. They do a great job of giving the pilot a much better understanding of what their airplane is doing, assuming that the mechanic is allowed to actually install this system correctly. In this case, the mechanic working on this aircraft was only partway through the installation of this system, and he was interrupted. He needed to get a torque wrench or some other type of wrench, and so he installed this fitting finger tight and left the engine cowling off. And when he left the hangar to find these tools, and I think also grab lunch or something, the pilot decided that he was going to fly the airplane regardless of what he believed the maintenance status to be on it. He didn't check the logbooks. He didn't wait for the 337 to be completed for this alteration. He slapped the cowling on himself and he decided to fly. And during the time that it took to get the engine run up and for the airplane to depart, this fuel line backed off, disconnected, and caused an engine failure. Unfortunately, the pilot was able to land kind of on the airport infield, as you can see here. He substantially damaged the airplane. He was not hurt. His passenger was not hurt. However, this is kind of a classic case of a fuel flow interruption here. We had the maintenance was incomplete on this airplane. The fuel line was not properly installed. And so this is what you'd call kind of a garden variety fuel flow interruption accident here. Rolling on into another case study here, we have an accident that occurred about 9 years ago to a Vans RV-12, which is a pretty cool kit-built airplane that went out to its owner, and the kit went out to its owner in 2009. And this dude hustled. He got this thing done in less than a year, and I'm told this is quite an intensive build for an aircraft. It usually takes more than a year. It usually is one of those things where it's like terminally in the process of being built. But this gentleman was able to, chip away at it and complete this airplane in about a year. During the initial climb on the day of the accident, the engine failed. Airplane was not able to return to the airport, and he performed a forced landing. He did not have many good opportunities to find a suitable landing site for this forced landing, and unfortunately he put it down in kind of like a paper mill yard with a bunch of equipment in it. He was fatally injured. One of his passengers survived, but he also had another fatally injured passenger. So you can see here, aircraft came to rest in this yard, and he really didn't have any opportunities to find a good, suitable landing site for it. It was very unfortunate. When I was not a participant in this accident investigation, but when the NTSB person, investigator, did the examination of this airplane, she found RTV lodged within the fuel system of this aircraft. So as you can see here, the RTV bandit has made an appearance, and we have red RTV present in the, used as kind of like a thread sealant. I don't understand the intent here. But it looks like he used it to help install, this is a fuel flow transducer, and put it on the threads of the fuel flow transducer, installed it. And as you can see, pieces of this RTV have flaked off and have basically made multiple blockages of the fuel system in many places here. RTV is not, it's good for a lot of things, but thread sealant is not one of them, because it seals those threads so good. It seals the lumen, the internal passageways of your fuel system as well. So they look at the aircraft records and examination of the aircraft, and you see this fuel flow sensor that is just chock full of RTV. He'd put it on about 2 to 3 weeks before the accident, and a witness came forward later and said that he had seen the pilot / builder using RTV as a thread sealant and told them to cut it out. This is not an appropriate thread sealant. Build manual for the aircraft stated that fuel lube or an equivalent should be used in these on these threads. And I shouldn't need to tell anyone this, but RTV is not an equivalent to fuel lube. It should only be used when it is specifically called out for that purpose, and this is not one of those times. So rolling on into another case study here. This was not, I didn't investigate this one, but it was really interesting. I kind of wish I'd been there for this one. So today we are talking about Piper Aztec, which is a pretty cool airplane. I really like them. They are a large, somewhat larger twin-engine aircraft, really well prized for their useful load. They can carry about anything. They've got kind of a nickname that is probably too crude for this broadcast, so I won't, that talks about their ability, their load-carrying ability. But this aircraft was being used as a training aircraft for pilots seeking to get ratings in multi-engine aircraft. And it, for about a week up until this accident, had been having some issues. The pilots had said that on the left engine, when you had it selected to the main fuel tank, the left wing main fuel tank, it had multiple tanks in each wing, it would kind of run rough sometimes. It was really weird. It would run rough. Sometimes the engine would like stumble. Sometimes it would lose engine power and then come right back. It was presenting very odd kind of indications going into this. They didn't, it's not understood if they just didn't tell the maintenance group at their flight school about this, or if they were told and it just went over their heads. It's not really known, but there's no documentation in retrospect of any of this being addressed by maintenance, any inspection or repairs done to the airplane. So on the date of the accident, this airplane was departing its home airport in Tennessee, Springfield, Tennessee, and it kind of had a very sluggish takeoff roll. And immediately thereafter, after it took off, the left engine failed completely and the propeller could not be feathered. They were unable to continue flight in the aircraft, and it crashed into trees beyond the runway. Both pilots were injured, but they were able to walk away from the aircraft. They were very lucky to walk away from this aircraft. This thing was pretty trashed, very badly damaged. Both wings broke off, as you can see here. The cabin came to rest inverted, and they're very lucky that they didn't hit their heads. The cabin didn't collapse, and they didn't receive head injuries from landing inverted in this stand of trees here. Very, very lucky indeed. So get this. This is what we find, or what the investigators found in this left main fuel tank. As you can see here, in the picture to the left, we've got a picture of duct tape. This is a duct tape that was found floating within the fuel bladder of this aircraft. And it had been there, it kind of looks like it had been there quite a while, because the fuel had eaten away the silver and the silver part of the duct tape and had eaten away the adhesive. So it was kind of this ribbon that was free floating within the fuel in this tank for quite some time. Not only that, if you look to the picture on the right, that is the fuel outlet. So that is where the fuel goes to go to the fuel lines, to go to the pumps and the selectors, to go to the engine. And it was missing a fuel screen. The inset on the right shows what the fuel screen should look like. It's kind of it's called a finger screen. And it is there to prevent FOD that could be in the tank from entering the line, and also give a larger surface area. So if you do have something that's trying to block that outlet, it takes more surface area to cover to properly block the outlet. And so when the tank had last been installed, that finger screen did not get installed with it as it should have. Looking at the tank material, it actually looks pretty good. It looks supple. You don't have a lot of the dryness, the crackiness, the distress that you see on an older tank. So the tank itself was in good shape, but it was missing that fuel screen, and it was missing its, and there was tape in it. So again, we see this tank in there, and what we think was happening was we saw glue that was on the tank cap, the fuel cap, and it kind of sounds like they were trying to use this as a to help seal the tank a little better, which is kind of silly. It's likely the tape had been floating around the fuel cell, periodically adhering to the fuel tank outlet, resulting in fuel flow interruptions. So probably what was going on was causing this intermittent nature of the engine roughness. There we go. Was that this tape had been adhering to the outlet. The engine would die because it would not have fuel flow, and then the suction would cease because it was no longer pulling fuel, and the tape would float off. This introduction of FOD into the tank was 100% what caused this accident and the loss of the aircraft and the injury to the pilots. Probable cause was considered to be the flight instructor's failure to abort the takeoff, because it did have a sluggish takeoff roll. He should have maybe seen that there was a problem, a mechanical problem with the airplane, and aborted the takeoff. But also causal was the inadequate maintenance of the left fuel cap by unknown maintenance personnel. They taped up the cap when they should have just replaced it or done whatever the maintenance manual says is appropriate for that, which resulted in a blockage of the fuel supply from the left wing tank. Fuel flow interruptions can be caused by FOD, the tape, can be caused by wear or damage to fuel selectors or improper installation of components like that fuel line. You should always look at the aircraft service or maintenance manual when performing maintenance. You've got to follow that. You can't be creative and come up with your own solutions for how to put things together, especially when they involve RTV and duct tape. Nothing ever at any time should be fixed by duct tape on an airplane. I mean, notwithstanding that airplane that got taped up after it got ripped up by bears in Alaska. If you haven't heard that one, Google it. You're sure to be entertained by it. When inspecting fuel selectors, be alert to symptoms such as binding, roughness, or any changes to operation. I tell this to pilots very frequently, and it should be, in my opinion, a rule of thumb of any interaction with an airplane. If you are interacting with an airplane for a period of time, you become familiar with it, and the behavior of the airplane suddenly changes, that should always be a red flag. Airplanes do not have moods. Either they are mechanically in good condition and they are doing as they are supposed to, or they are not. And any changes to their behavior or their operation should always be investigated. Things should not change. So if you have an airplane that you have been maintaining or flying or interacting with in some basis, and suddenly it is doing something different than the last time you interacted with it, you should always look and see what is causing that difference. Could be something innocent like, the pilot had another mechanic install something or change something on it, or it could be something bad happening. We have an example here. This is a fuel selector, an old style PA-28 fuel selector. And they're kind of garbage, unfortunately. You still will see some in the field, although there is a service bulletin or service letter, I don't recall which, that recommends the replacement of this item for a updated one that you will see on more recently built aircraft. But this particular aircraft, the fuel selector was worn enough that it lost or lacked, there we go, pick a word, lacked a tactile detent, so that the pilot could not feel when he switched the fuel tank, the fuel setting, if he was actually in the off or the left or the right tank selection. So fuel selectors should always have a tactile detent, meaning that when you turn it to on, both, off, left, right, whatever selections this fuel tank selector has, you should feel a click or feel a detent. If they do not have that, that's probably meaning that the fuel selector has worn and is past its useful life. In this case, the pilot put it in between fuel tanks, as you can see there, because it's kind of in a challenging position to view and wasn't able to get it in the tank selection that he wanted, and ended up starving his engine of fuel. Fuel flow interruptions can also be caused by blockages to vents, because as the fuel is being drawn from a tank, it has to have air come in to replace the fuel that is leaving the tank, or else you will have negative pressure within the tank that can either cause fuel flow interruption because it can no longer pull that fuel out, or you can straight up crunch the tank. If the fuel pumps are strong enough, it can suck down the tank and crunch it like a bottle, basically. If you wanted to visualize what I'm talking about here, if you take a bottle of water and you like drink the water out of it without letting any air in, it's going to crunch down the water bottle. Tanks are not really meant to take a lot of positive or negative pressure, and by a lot I mean anything more than a PSI can probably start to do damage. I don't remember what this aircraft type is, but he had a blocked fuel vent, and he had probably his electric fuel pump on at the time, and he was able to crunch down the tank, which is pretty hair-raising. He heard a bang and looked out and saw this, and so not only do you have this potential fuel flow interruption in the engine, but you have a wing that's lost a lot of its aerodynamic shape here. That must have been startling. We have vents here on a PA-28. This is one that I investigated a couple of years ago, and I don't believe was present at the time of the accident. This happened in the months that the airplane sat at a storage facility awaiting examination. But on the left, we have a tank vent that had a spider living in it. Gross. And on the right, we have the fuel line that usually goes from the wing to attaching to the fuselage here, and a wasp or something stuffed this thing like 3 inches deep with leaves. So this can happen in a very short amount of time. Insect activity, they like to plug things up. I don't understand that obsession, but they will do it. So much in the same way that a pitot tube can be blocked by insects, you could have vents or tubes exposed that are left open that can be blocked as well. And so be alert to that. I like to use clear plastic tubing to test fuel lines and vents for blockages. It's very cheap. You can get it at Ace Hardware. I advise looking for the 3/8-inch diameter tubing because you can use it to blow air through these lines to see if they're blocked or not. They should be able to pass air through very easily. And if you have the fuel system open for any reason during maintenance, it's a good idea to get dust caps or cover the open ends that are exposed to the outside, because bugs will find them. Fuel leakage can result from wear or damage to components, improper installation, poorly maintained or improper seals, or because of venting. And this is dangerous because you can lose all your fuel and your engine can fail, but also it's a fire hazard. Interport fuel leakage is something that's very interesting. It is where fuel can seep from one tank to another through the fuel selector. And it's not a really well-known phenomenon, I find, and it can be dangerous because now you have the potential for the pilot to mismanage their fuel based on this fuel not being in places where he anticipated. And then also, if fuel leaks interport to a tank that is already full, it will be vented overboard, so it becomes a fuel leak at that point. We have here a Piper Chieftain that was on its takeoff roll. This is crazy. He was on his takeoff roll, and he started having engine issues. I think he noticed that he was having lower map on one engine than the right, so he aborted his takeoff, thankfully. And as he was slowing to a stop, his right wing exploded. Turns out what had happened was he had a rubber fuel cell, much like the one that was seen in that Aztec, fuel bladder, whatever you want to call it, and it had gotten dry rotted, and there was a kind of a nipple that was a part of the fuel venting system that had broken off because it had just become so dry, very dry, very brittle. And so this started dribbling, leaking fuel and allowing vapors to enter the wing. And meanwhile, we had a wingtip light wire that had been chafing on a wing rib, and it had been sparking. So you had kind of this nightmare scenario where you had leaking fuel that was trapped within the wing with these sparks that were potentially flying. And so this is the result right here. It's very fortunate that he aborted the takeoff and he just happened to have some kind of engine issue. And did not try to take flight with this because I do not think that the result would have been very good at all, honestly. We have here, this is a Diamond, I believe. Diamond DA40. I'm not very familiar with them. Anyways, we have here a fuel tank, and I believe those are installed behind the cabin in the fuselage. And as you can see here, we have some cracks around the rivets, kind of to the left line of rivets that you see here in this image. And it looks kind of like, to me, maybe the skin was kind of oil canning or flexing around the heads of the rivets, which caused cracking. And some of these are leaking, as evidenced by a great deal of fuel staining here. Anytime you see fuel staining like this, it should always be a reason to investigate further, even if it's a little difficult. I imagine this laying on the belly of the airplane or however it's installed made it difficult to visually see, but if you smell fuel or you're seeing this bright blue fuel staining that looks fresh, it should be very suspicious to you, and you should always want to follow up on that. Now, this gentleman who found this line here deserves some commendation, because this was in a very difficult area to see, kind of behind the door, the left cabin door of this Cessna 180. And we have two major issues here. We have an aileron cable that is wearing against something, and they really should not be touching anything other than fair leads or pulleys. We have this thing sawing, garroting into the fuel line coming from the left-hand fuel tank. And this cable succeeded in getting, looks like, a good ways through the material of this fuel line here. And it would have been a disaster had this sawed all the way through, because you have all of that fuel, and I don't remember what the capacity of each tank is in the 180 Jag, but we have all of the weight and the pressure behind this, all of the fuel that is in the left-hand tank that is now bearing down on a hole that's in this line here. So I imagine that had this airplane been in flight, it immediately would have been spraying just like a fire hose into the aft door post here. So it would have been an incredibly dire situation had this happened in flight. But this person did a very good job finding this and being able to photograph it. I guess he had to do some like magic, like some kind of razzle dazzle with a cell phone or a borescope to photograph this. So this is a recent accident that I participated in the investigation of, and it is in the preliminary report stages of the investigation. So I cannot talk too much about it, other than to provide you what was stated in the preliminary investigation, preliminary report of this investigation. This was an aircraft. It was a twin Comanche that was flying in the Dallas area, north of Dallas, and the gentleman had this aircraft looked like it had been in very good repair for quite some time under the care of its pilot owner, and it looked like he was very willing to invest in the care of this aircraft. It was clean, it was tidy, it had very good maintenance records, and it was hangared. He babied the aircraft, he liked it very much, but he didn't fly it for a little bit, and he decided to take a kind of a $100 hamburger / buying fuel at another cheaper airport flight. And during that time, he had either a partial or total power loss to both engines. We are still determining that. And when this aircraft was taken from the accident scene to a wreckage yard in the Dallas area, and we looked at it, I decided to at first sump the fuel from the two fuel selectors that are on the belly of the aircraft. On this type of aircraft, the only fuel sumps on it for each side are in the fuel selectors, which are in the belly of the aircraft. You don't have tank drains for each tank like many aircraft do. And I noticed that it was dribbling very slowly from both sides, but from the right fuel selector especially. And and that was odd. There was a couple rust flakes in it, which was not good. And when I was finally able to take that fuel bowl down, this aircraft, the fuel selectors and the fuel bowls are kind of like one assembly. When I took the bowl down, it was completely packed with rust. It looked like chili, like chili dinner or something. It was just rusty. It was pasty. It was thick with rust. It was terrible. And so we had probably was the result of water being in the fuel system for some amount of time. We don't know how much, which is somewhat unexpected with an airplane that is hangared and is not being rained on. However, it is a phenomenon that is understood because since the airplane's fuel tanks vent to atmosphere, you can have condensation. And so if it's humid, like Texas can be sometimes, you can have condensation. So condensation enters the tanks and goes to the bottom of the fuel system, which happens to be the fuel selectors. In this case, we also had we kind of had some problems with the ports in this fuel selector, so they were not closing as they were supposed to. So it was very possible that you had fuel being drawn from multiple tanks simultaneously. And to me, the biggest deal here was that when you tried to turn the right-hand fuel selector handle, it was grinding. It was not moving smoothly. If you are a pilot or you are a mechanic and you feel something that is not, especially a fuel selector that is grinding, is very difficult to move, that is a problem. It should be easy. It should move smoothly. It should not have to be forced, and it should have detents that you can feel click. It should be clicky, obvious detents. So if you have these issues where suddenly, especially this develops over a time period of a very short amount of time, something is going wrong. Fuel selectors should move smoothly, and if all of a sudden this airplane presents to you and it's suddenly grinding, difficult to move, this should be considered a huge red flag. You should be investigating this. And again, always observe what the service manual or maintenance manual tells you what to do and what those recommended time limits are. Always be alert to the rubber components condition. So if you have flexible hoses or fuel bladders, they should be flexible and supple. They shouldn't have a chalky, dry appearance to them. They shouldn't be hardened or cracked, because hardening and cracking of these components should warrant replacement. No chafing of the components should be present either. They shouldn't have like things poking, prodding, rubbing on them, things like that they can cause damage or an eventual leakage. Fuel contamination happens unfortunately very frequently, and usually the biggest contaminant or the most frequent contaminant that you're going to see is water, like I mentioned in the slide with that twin Comanche. Even hangared aircraft can have water enter their fuel systems through condensation. Fuel cap gaskets can deteriorate and allow in rain if the airplane gets rained on outside. And again, going back to our Aztec accident, taping up the gaskets with duct tape is not an appropriate way to remedy a fuel cap that is leaking. Water can cause rust and can another contaminant. So not only is water itself a contaminant, it breeds other contaminants. It never gets better, it only gets worse. And so you can also have other contaminants such as sealant, RTV that we mentioned earlier. You can have other FODs. You can have fuel tank sloshes or sealants. Sloshes are specifically forbidden in a lot of different aircraft types. I don't believe any of the Piper products are allowed to have sloshes in their tanks. And for those who are unfamiliar with what sloshes are, it's where you can seal a tank by pouring in the sealant and then sloshing it around in the tank, and it covers up any defects that are on the interior of the tank. It's kind of I don't know, it sounds really sketchy to me. We can have here, this is a prime example of what water will look like in fuel. I'm sure maybe all of you know what that looks like, but we have here a very good example of that. Not only that, it looks like we've got a little bit of rust in there too. So in the case that you find water in your tanks, you can drain it, but when you start seeing rust in here, it means that some damage has occurred. Rust doesn't occur unless damage has occurred. So if you start seeing rust, it really goes, you should be taking it beyond just a draining of the tanks and getting the water out. It should start being one of those things where you start really examining the fuel system in this aircraft, because you cannot trust rust. It means something bad is happening. It's never good. Never, ever good. This is a PA-28. I believe it was a 181 that I assisted in the investigation of. It was an aircraft that crashed, performed a forced landing, attempted forced landing onto a road in Greece somewhere after its engine failed. And examination of the right-hand fuel tank revealed this disgusting garbage. I don't know what it was. We never figured out what it was. They did a spectroscopic chemical analysis of it, but we never were able to figure out, based on those results, what this chemical was. It was some type of sealant. We suspect it was used in the repair of a fuel storage facility that the aircraft had visited at some point. And the results of this contamination, as you can see here, if you look at the lower right picture, that is the gasculator screen for this aircraft. And this image to the left of this screen is a close-up of what the screen looked like. And you can see it's very thoroughly contaminated. It's very thoroughly blocked by this chemical. And everything else that had happened catch. So not only do we have this chemical, it looks like we have hairs and, I don't know, sand or something. So this was very likely caused by some type of mishandling of the fuel before it was loaded to the aircraft. Unfortunately, this investigation happened in another country that was under, I believe, COVID restrictions at the time. And so they were never able to really suss out where this fuel had come from or what had caused this type of contamination, unfortunately. But this is a very good, very visually striking example of what contamination, how ugly it can truly be, and what the outcome could be. This was a 3 fatal accident to this PA-28. So we have here the sealant of I believe it was a Baron, a Beechcraft Baron fuel tank here. And I don't know all too much about Barons, unfortunately, but it looks like maybe the sealant that was used was not the proper sealant, or it was just incredibly old. So we have this flaking of the sealant that has happened. And I do believe a lot of this FOD that you're seeing here is from them basically drilling up and removing the skin, including these rivet heads here. But a lot of this was present before the tank was open. These flakes of sealant were found throughout the fuel system of the aircraft, if I recall correctly in this report. And I'd also like to point out the presence of the rivet heads in the right-hand picture. And this is, I mean, ostensibly from when this tank was opened by the mechanic who presented this image. But just a word of advice to those working in sheet metal. I'm sure as many of you know, you produce a lot of FOD when you are doing work to your aircraft, especially when you are removing rivets, things like that. They can get anywhere. And so if you're working on an airplane, be very careful for where your rivet heads and butt tails go. All of these little shavings of metal can very easily enter the fuel system of an airplane and be very problematic. I've in the field seen many fuel tanks and other places that were just chock full of butt tails and rivet heads that have been removed at some point and not vacuumed out, and they can be very problematic. So not only do we have this sealant that is flaking, cracking, breaking, we've got rivet heads here too, and I'm sure this person vacuumed them up, but this is visually a good example of how a lot of these little rivet heads and butt tails can enter fuel systems too. This was another recent accident that, since it's a Cessna, I did not participate in the investigation of this accident, but we have here, it's a Cessna 150 that crashed on September the 6th, and it was a fatal accident that took actually a friend of a friend. One of my friends worked with this gentleman. He was a corporate pilot at the time, if I remember right. and that pilot's son was with him, and they both perished in this accident that happened shortly after takeoff. The engine failed. And if you were to review the report, the preliminary report on the NTSB's website for this accident, you will see the following pictures, which is this hideousness. I don't even know what that is blocking the fuel lines here, but this disgusting contamination of the fuel selector and one of the lines here. And I don't know what that is. It does not belong there, and it's looking so far like this was a huge part of what went on to crash this aircraft, unfortunately. I don't know what the symptoms of this contamination would have been. I don't know if they would have, on 100-hour/annuals, been seeing flakes of something downstream of these components here that could have warranted further investigation. But all in all, a good, very sad example of what contamination can do to an airplane and what it looks like. Another source of fuel contamination comes from fuel handling during maintenance. Many maintenance activities involve defueling of the aircraft. So for instance, if you have to change a fuel selector or repair a tank, you're going to have to defuel that tank, or all tanks on the airplane, depending on what the maintenance manual tells you. And it can be very, very, very easy to contaminate the fuel while you defuel the airplane. So very common to see metal drums, you know, those big 55-gallon metal drums, oil drums, whatever you want to call them. It's very easy for those to be contaminated, much in the same way that fuel tanks do. So you can have dust and debris, FOD, that falls into them, and then you can also have condensation that forms on the walls that makes water accumulate within them. There are some sources on how to handle fuel. The FAA, the far to my understanding, may not have anything in them specifically to what a maintenance person would be doing, but the U.S. Department of the Interior actually has a manual called the 351 DM1 that gives some guidance on how to handle fuel properly so that you're not introducing FOD or water back into the aircraft when you refuel it. Personally, one time when I was doing maintenance on a PA-28, I was doing a replacement of the fuel selector, which necessitated me to drain both the tanks. And when me and another mechanic drained the tanks, we drained them into a metal barrel that, I stuck my streamlight in. I looked, it looked very clean at the bottom. We put the fuel in there. We replaced the fuel selector. We took the fuel back from the drum into the airplane. And when we sunk the tanks, there was just water everywhere. Because even though fuel is very clear, when you're looking down through the neck of a drum, it can be very hard to see the water that's at the bottom, unless you look at it kind of sideways, like in that fuel sampling jar a couple slides ago. So it's very, very important to have some sort of procedures for examination of the containers that you're using to defuel aircraft. Quantity indication errors. So this is a kind of a big one. Although pilots are required to calculate the fuel consumption for every flight, inaccurate fuel gauges can cause accidents because pilots can see this fuel gauge and that's showing an incorrect level and kind of doubt their own calculations that they made beforehand. They can cause misfueling as well. They take on less fuel than they anticipated or more, can cause weight and balance issues. They can also cause, like I said, weight and balance issues. So if you have tanks that are indicating or gauges that are indicating less fuel than is actually on board, the weight of the aircraft and the balance of the aircraft can be different than the pilot had calculated. So we are going to go on to the centerpiece of this presentation here, which is the background image that you see here, which was a 2822 Foxtrot, which was a 1979 Piper Seneca 2. And day before the accident, the pilot had fueled the aircraft up at Glendale Airport in the Phoenix area, and he had used the airplane's fuel gauges on the panel to determine the fuel level of the aircraft when he was fueling it. So he was fueling the aircraft, and then he was looking in at the fuel gauges on the instrument panel to determine how much fuel he had, because he didn't want to top the tanks. He wanted partial fuel for his activities in the following days. And the Seneca is kind of a weird airplane. It has multiple tanks in each wing, but you only have one filler. So you have to rely on either the little, you have to dip the tanks, or you have to, on some of them, they have a little gauge that will say what the inboard tanks have on them. But it's kind of tricky to figure out visually what your fuel level is on these, which is not too rare in the aircraft world, unfortunately. But he fueled the aircraft, and when he looked at the gauges, he believed he had 40 gallons of fuel per each side, so 40 in each wing, 80 total. So, as I'd said before, this airplane has two fuel tanks in each wing, but you also have an option for a third, and this is what the airplane had. It had three fuel tanks in each wing. The outboard tanks feed into the inboard tanks in each wing, so only the outboard tanks have fuel supply, or only the inboard tanks have supplied the fuel to the engines, and only the outboard tanks have fuel cap, basically. And each tank, each of the main tanks or metal tanks has fuel sensor in it, and they're kind of wired in series. So you only have one gauge per wing. So in effect, although you might have multiple tanks in each wing, you have they kind of act like one tank functionally. You can only select one side, and you only have one gauge, so it's in effect just one tank, I guess you would say. And this is kind of the diagram out of the POH of the airplane. So as you can see here, functionally you only have one tank per wing, although physically there's multiple tanks. It's confusing. I'm not explaining this very well. So on the day of the accident, aircraft performed, it had done some cross-country activities throughout the state of Arizona. On the morning of the accident, he boarded a passenger in, I believe it was either Payson or Sedona, Arizona, and decided to fly into Deer Valley Airport. And when en route, he noticed that there was a fuel imbalance. So one side of the aircraft was indicating more fuel than the other, and so he decided to cross-feed from the fuller side and balance out that fuel without maybe wondering why he had a fuel imbalance in the first place. But when he was on final to Deer Valley, he noticed that both of his engines had failed. As you can see here, we have the aircraft's approach to Deer Valley. And the pilots might kind of question, me included, I'm also a pilot, but you might question why maybe he didn't fly a tighter pattern at a higher altitude. And it could just be separation for traffic that was existing in the area. But as you can see here from the ADS-B data, this aircraft did not make it to the runway. And he ended up crashing short of the runway here. Let's see if this works. So the investigator is right away that this guy, as he comes down, splash, look at that, splash down. There's fuel there. So this wasn't, when I first got this video, even before I'd seen the airplane or done an examination on the airplane, obviously we have some fuel on the airplane here. So this wasn't straight up, no joke, I've exhausted all the fuel on the airplane. We had enough to make a big splash as he touched down on this road short of the airport. Just for fun. Splash. So comes to rest in a street here, and he and his passenger were a little injured. They went to the hospital. I think they were treated and released, fortunately. Usually people do not get so lucky. Deer Valley Airport is actually my home airport, and I used to do maintenance functional check flights for a flight school that was based there many moons ago. And I definitely spent a lot of time considering what my options would be for forced landing sites in this area off the departure ends of the runways. And there are not many options. So this person was able to destroy and litho break his airplane through a ton of cars to basically come to a stop here and survive and basically walk away from the accident site. And this I happen to live close, and so funny enough, I was having my morning coffee, and my Ring doorbell app on my phone alerted me to this safety occurrence of an airplane being in the street, and so I was able to get out of my pajamas and drink the rest of my coffee in a hurry to go see if it was an airplane that I supported and would be investigating. And sure enough, I see a Piper. So I was able to get on scene in record time for this one. Fortunately, these gentlemen were able to walk away from this. I'm honestly very relieved. So we have here the airplane as it sits at the wreckage yard, and as you can see, the nose was destroyed and the right wing was in pretty terrible shape. And we have some super ancient fuel level sensors that were pulled from the wings here. We have the left inboard and left outboard here. And so to troubleshoot, at this point we'd kind of had, based on what the pilot statements were, we kind of had some inkling that we had a problem with the fuel level indication of what this airplane was telling it had on board for fuel. And so we wanted to test the fuel system of the airplane, but as you can see, the right wing had been destroyed on this aircraft, and the left wing was in pretty bad shape and had been cut off during recovery. And so what we did was we leveled the wing to try and make it as close to what the airplane would be as it stood on the ramp, and used flex tape and basically taped up the fuel tanks so that they would be able to hold liquid again. And we put those fuel level sensors back and applied power to the aircraft. It actually battery power. If you turn the battery master on and you had a battery available, it would still the instrument panel would light up. And so we followed the maintenance manual instructions for how to test the fuel level sensors on board the airplane, and we filled these fuel tanks that were flex taped up, and basically filled them in 5-gallon increments, if I can remember correctly, and were able to test the fuel level sensors and the fuel gauges for this airplane in this way. And as you can see here, when the left fuel tank was empty, it was still indicating that it had 10 gallons on board. So this is before we even started adding water to the tanks to test what it was saying. And so not accurate. The left wing fuel sender units and the fuel gauges indicated the fuel levels significantly higher than what was present in the fuel tanks. And although the indication discrepancy of the right wing fuel sender units was greater for fuel levels in the tank of 30 gallons, the indication was mostly accurate. So we ended up finding out that and we'd swapped in the fuel level sensors to the left wing too, the right-hand ones, and tested those too. But they were not super accurate, but they were I guess closer than the ones on the left. And so we had some pretty significant differences on what the actual water level was in the tanks versus what the indicators were saying. And so basically what we ended up finding out happened was that this pilot had fueled the tanks. He looked at the fuel gauges on the dash, which were inaccurate, and he fueled the airplane with probably a lot less fuel than he anticipated than the airplane would need for these activities. And so he believed he had 80 gallons. He probably had much less than 80 gallons on the airplane. And so when he went to basically cross feed the right engine from the left tank, which he believed had much more fuel than it had no fuel in it. And so both of his engines failed, and he was unable to make the airport. So the pilot's mismanagement of the fuel on board, which resulted in a loss of engine power, and contributing was the fuel starvation was the erroneous indication on the fuel gauges. So I know a lot of us a lot of our checklists don't say that you need to ops check the fuel level sensors on board an airplane, but it really should be something that you should consider bringing up with your pilots or the operator of the aircraft, is to maybe take the time to look at those procedures, bring that airplane into the hangar, defuel it, do whatever the maintenance manual says to check the accuracy of the fuel level sensors. I'll also point out that there are digital fuel level sensors that are on the market that so far seem to be much more accurate and more reliable than the old school fuel selectors of the 70s and the 80s. And so food for thought. I mean, consider recommending those. I do believe a lot of them require a special power wire to be installed for them to work, but really it's really good to have fuel gauges that are actually working, believe it or not. And this last accident is definitely a case study of that. In conclusion, always be familiar with the aircraft's airworthiness directives, service bulletins, letters, instructions in or service manual or maintenance manual procedures. Any changes to the aircraft's performance or feel should be investigated. If it starts changing, if it starts doing things differently than it always has, it's really time to follow up with that, especially when it comes to like the feel of the fuel selectors. If you feel grinding or there's a lack of detent all of a sudden, it really should be time to investigate that further. And fuel leakage should always be investigated because you are losing that fuel that the engine absolutely must have on board to be operating. And then not only that, you can have a fire or an explosion take place if it's leaking into a contained area. Be FOD aware and observe fuel handling best practices. So one thing that often happens that I suspect causes a lot of FOD out there in low-wing aircraft is the propensity of people, pilots included, to set things on the wing outboard of the fuel filler, and things roll down because the wing dihedral into that tank. I've seen it happen myself, and it sucks. And then pilots always be observant of the POH recommended procedure for sumping and sampling fuel from your aircraft. Going back to that twin Comanche we talked about earlier, that has some very specific recommendations on how to do that, and you really need to be, as a pilot, aware of those, because some aircraft are more sensitive than others to having contamination present within their fuel systems, and some have much worse outcomes because of that contamination. Not all aircraft are same, the same behaviorally. So if you need to do a lot of something and be very diligent, then that's what you got to do. And that's just a fact of life with aircraft. They can be the situations in flying can be incredibly unforgiving, and a fuel system is one of those things where it works great until the second it doesn't. And you do not want to be left high and dry by an aircraft that has not had its maintenance or operational procedures followed. So that's my presentation for today. I hope this was enlightening for you guys. And it was good to be back with you all again this year. Thanks to all those who reached out to me last year. If I didn't respond to you, please don't take it personally. For some reason, Piper decided to get a much more effective spam filter put in that was so effective it filtered out almost all my email for quite some time. It was it kind of sucked. But again, thank you for your attention, and be safe out there, and hopefully I'll be back next year. Take it easy.